So let's take a look at section 4.4, exercise 62. And in this, we have a word problem. We're told that the blood flow, the velocity v of the flow of blood at a distance r from the central axis of an artery of radius r is, okay, so our flow velocity, okay, so this is a rate, k times uppercase r squared minus lowercase r squared. And so what this says is as you're toward the middle, so little r would be 0 at the middle. The velocity is bigger at the middle and much lower out at the edges of the artery. Okay, so constant of proportionality k. Find the average rate of flow of blood along a radius of an artery. Use 0 and r, uppercase r, as the limits of integration. Okay, and so our average here is just the integral from 0 to uppercase r of k r squared minus little r squared dr, and all divided by our r minus 0, the width of our interval. Okay, so that's, I can factor out the k, so I get a k over uppercase r times the integral from 0 to r of r squared minus little r squared dr. Now, notice it's dr. That's a constant, uppercase R. So this is k over r, and we're ready for our fundamental theorem of calculus. Okay, this, the antiderivative, that's just a constant, so that's uppercase r squared times little r, and then minus r cubed over 3, and this is from 0 to uppercase r. Alright, well, that's k over r. We get uppercase r squared times uppercase r when we plug that in, minus uppercase r cubed over 3. And then when we put 0 in for lowercase r, we just get 0, so minus 0. So this is k over uppercase r times r cubed minus r cubed over 3. Well, that's then 2r cubed over 3. So this is k times r times 2r cubed over 3. Now simplifying a little bit more, we get that our average flow is k, 2k over 3, and then r cubed over r is just r squared. Okay, so there is our average, and that is number 62.